All right? So I need everybody paying attention because we want to get off on the right foot with this because this is a biggie. This is something we're going to use a lot. So everybody's got your in-class practice for 1.3. And I'm going to show you what the segment addition postulate looks like. We're looking at our in-class practice. We've got notes for this too, but we never get through everything, so we'll just work on this, and then we'll go back to our notes if we have to. All right? So here we go. It says, write the segment addition postulate for the points described below. Draw a picture to help. So, I'm going to draw a line. This is problem 1. S is collinear with and between D and P. So here's D, here's P, and S is in between. S is collinear with D and P and between D and P. Does that picture make sense to you? All right. The segment addition postulate says that if we take DS and add SP, guess what we get? If we take DS and SP and add them together, what do you think we get? DS and SP, what would they make if we added them together? DP. Yep. That is your segment addition postulate. That's it. That's all there is to it. Okay? So let's see if we can draw the next one. Number 2. J is collinear with and between S and H. So they're all in a straight line. And J is between S and H. Derek, do you need to move? Can you see okay? So J is between S and H, and they're all in a straight line. Does that picture look okay for number 2? So what does the segment addition postulate say for this one? SJ plus JH, very good, equals SH. So piece plus piece equals whole. All right. See if you can draw number 3. This was 2. See if you can draw number 3 on your own. Draw a line, put 3 points on it, and see if you can label those points. C is between Q and R. How does that look? Does that look okay? Scout?
I'm just wondering, why are like S, C, J, why do those get cut out? Like in 1, 2, and 3. Like why did the middle
You mean in the final answer?
Yeah.
Okay, because the idea here is, first of all, when you name a segment, you only need 2 letters. So if I want to name from my finger to my finger, that's going to be DP. That's how I'm going to name that. Now, is S still in there? And a whole bunch of other points are still in there, but I don't name them.
Okay.
When I do my segment addition, though, I'm taking the little segment, so I have to use C because I want the little segment, and then I'm going to add this little segment, but those 2 together are going to give me the whole thing.
Okay.
Segments always use 2 letters, and if it's a segment, you use the ones on the end. So QR is the whole thing.
Okay.
But to get QR, I'm going to add QC and CR. And that's going to give me QR. So remember, piece plus piece equals whole, or little plus little equals big. All right, how about number 4? Do you have that one done? We got M and N and T. So what did you say here? Eric? MT plus TN equals MN. Yep, that's exactly right. Little one, MT, plus other little one, TN, adds up to the whole thing, which is MN. Now, the reason that these are so much fun is because there's a lot of algebra involved with them. So let's look at the next set. Draw a picture. Okay, so here's my picture. I have A and E, and I have C in between. Now, I keep putting it like it's right in the middle, but it doesn't have to be. It's somewhere in there. Now, look what we know. AC is 24. CE is 13. So we want to know AE. What is the whole thing going to be? Yeah, that's easy. 37. Because piece plus piece equals whole. All right, so I got the same picture. All right, CE is 7. AE, AE is 23. Can you find AC? What do you think? 16? How do I know it's 16? It's 23 minus 7, right? These two have to add up to the whole thing. All right, I want to skip now because we're not going to have time to do the whole thing. So I want to skip down to number 9. If we end up having time, we'll come back and fill it in. But let's skip down to number 9. They drew the picture for us. So here's A and B and C. This is 2x minus 8, and this is x plus 17. Now, it tells me in the problem that AC is 39. Can anybody give me the equation that I'm going to set up to solve this? Declan?
2x minus 8 equals.
All right,
Yeah, equals x plus 17.
now, do I know that these two pieces are equal? Did they tell me they were equal? No. What do I know about these two little pieces, though? I know that the little one plus the little one will add up to the whole thing. So you want to try again? 2x minus 8 plus,
X plus 17.
yep, equals 39. One more time, gang. Piece plus piece equals whole. That is your mantra. Little plus little equals big. Every time. So little plus little equals big. All right, how do I solve that? Who can remember? Yeah, Carson?
Do you, so do negative 8 plus 17?
Okay, so I can combine these two together. How about these two? Can I go ahead and combine those while I'm at it? So 2x and x would give me 3x. Negative 8 and 17. Actually, positive 9. And equals 39. Okay, now what? Subtract the 9. Good. Now I'm showing a bunch of work here. Some of you don't need to show all these steps. It's completely up to you. So I get 3x equals 30. So then I'll divide by 3, and x equals 10. Now, be really careful. Notice that the problem says find x, so x equals 10. We did that. But then the problem also says find AB. Now, AB was 2x minus 10, or excuse me, 2x minus 8. How will I find out how long it is now? Alec? Plug in 10. So 2 times 10 is 20, minus 8 is 12. So this is 2 times 10 minus 8, that's 12. And then I also need to know BC. So BC would be 10 plus 17, or 27. Now notice they aren't equal, are they? But do they add up to 39? Yep, which is exactly the way we planned it. All right, try number 10 on your own. It is exactly the same kind of problem. Remember, little plus little equals whole. Little plus little equals whole. Mia, did you get the same equation I did?
Yeah.
4x minus 3 plus 2x plus 21 equals 60? All right, Patrick, what'd you do first to solve this guy?
I combined it in -3 and 21.
Okay, and the 4x and the 2x? So we have 6x plus 18. That's just collecting like terms. We're not moving anything. Those of you that had Mrs. Field, you know that she likes to draw that in there. Now what? Alec? Subtract the 18. So I have 6x equal to 42.
Yeah.
And you divide by 6, you get 7. Now that's all hunky-dory and great and wonderful, but that isn't the whole answer, is it? So now we gotta go back. If you put a 7 in here, how big is this? 25. And if you put a 7 in here, 35. And your check is, those have to add up to 60. And they do. Nicely done. All right, let's see. Let's turn to the back side. So we are now on the back of the 1.3 practice. And 13 says, write an equation for each of these. Segment AB, you know how to write that. There's segment AB. And segment BC, you know how to write that. Does anybody know the symbol for is congruent to? The congruent symbol is an equals with a squiggly over the top. That is the symbol for is congruent to. And all that means is they're the same size. They're the same size. (14) says XY is congruent AB. Well, that's already an equation, but they want you to write it a different way. So the different way of writing this would be XY equals AB. Now, let's talk about this. This is one of these picky points in geometry. I'm going to try not to be super picky. Hopefully your new teacher won't be super picky either. But this is one of those places where you got to be careful. When you are talking about the shapes themselves, see how that bar's over that? That means segment. That means I'm looking at this segment and I'm looking at this segment. When you're looking at the shapes themselves, they're always congruent. This is how I remember it. See how they have a bar over the top and the equal sign has something on top of it? If you have these up here, you need the congruent sign. If you're simply telling me that the distance from X to Y is equal to the distance from A to B, you don't need any line over the top. Those are equal. So if we said, okay, AB is congruent to BC. Another way of writing that would be AB equals BC. So whenever we are talking about the shape, we have to use congruent. Whenever we're talking about its length, this is the length, this is the shape, this is the length. Oh, we got all kinds of vocabulary. Does anybody know what the word bisect means? What does the word bisect mean? Does anyone know? Have you heard that word before? Bisect means cut in half. Cut into two equal pieces. So if we have segment AC, I am on problem 15. If I have segment AC, if point B bisects it, point B is going to be right here in the middle. And your equation for that would be AB is congruent to BC. Because if that's right in the middle, aren't these two pieces the same? Or you could write that AB equals BC. Remember, all you're doing is writing an equation, so 16 is easy. 2x plus 5 equals 4x minus 8. You don't have to solve it or anything. You're just writing the equation. (17), we have segment PT, and A is the midpoint. What do you think it means to be the midpoint? So this is the same as bisect. If you are in the middle, right smack dab in the middle, you're like the bisector. So what would an equation be for this? You got a couple of different options. What would one equation be? PA
Congruent to, AT.
Perfect, Patrick, that is perfect. PA is congruent to AT. PA, AT, congruent if we know that's the midpoint. Or you could write that, PA equals AT. That would be another way of writing that. We're almost done. I think, I really have no idea. 18, RS is congruent to MN. So RS is congruent to MN. If RS is 3x plus 17, and MN is 7x minus 15, what are we gonna do?
Solve for x.
And how, so what's the equation gonna look like?
3x plus 17 equals 7x minus 15.
Bingo, that's beautiful. We know they're equal because the problem said they were. The problem said they're equal, so we're just setting them equal to each other. Let's quickly solve this. So if I subtract 3x, and I'll add 15, would you get 8? I did that kind of fast. Hang on to that. If we have a chance, we'll finish it tomorrow. I'm gonna hand out your homework and work your desk. Let's keep up the good work with our homework, people. You're doing great. Mr. Kennedy has graciously allowed me to sit in his room before school. That's 4237. 4237, so that's where you can find me. Before and after school, if you have questions. So everybody got a homework paper? You're gonna be doing some algebra tonight. Here I come, I'm gonna split to this. Scott, did you get the copies made?
Yes, no, I did.
Did you get your work with you or anything? Go down? Everybody's family staying healthy. Hopefully. Okay, so now we use paper towel. Another minute. When it gets to be 54, you can write.